Hello friends, in our last video we learned about the remainder theorem. Before we start our today's topic, let's revise it. So let p of x be any polynomial of degree greater than or equal to 1 and a be any real number. If the polynomial p of x is divided by the linear polynomial x minus a, then the remainder is p of a. So p of x is equal to x minus a multiplied by q of x, where q of x is the quotient, plus p of a, since p of a is the remainder. Now, if we suppose p of a equal to 0, then p of x will be equal to x minus a multiplied by q of x. So we can conclude that when the remainder is equal to 0 or p of a is equal to 0, x minus a exactly divides the polynomial p of x. In other words, x minus a is a factor of the polynomial p of x. We started off by taking x minus a as a divisor, and now we are talking about it being a factor. What's the difference between a divisor and a factor? Well, the difference between a divisor and a factor is a divisor divides a number resulting in a remainder. When that remainder is 0, we say that the divisor exactly divides the number, or it is a factor of that number. For example, in 15 divided by 6, 6 is only the divisor, since the remainder is equal to 3 but not equal to 0. On the other hand, 3 is a factor of 15 since it divides 15 exactly. That is, when 15 is divided by 3, the remainder is 0. So, in 15 divided by 3, 3 is a divisor as well as a factor of 15. Coming back to p of x, x minus a is a factor of the polynomial p of x since p of a is equal to 0. Now, this is known as factor theorem. The factor theorem states that if p of x is a polynomial of degree greater than or equal to 1 and if a is any real number, then x minus a is factor of the polynomial p of x if p of a is equal to 0. Now, do you think the vice versa is also true? That is, for the polynomial p of x, if x minus a is a factor, will p of a be equal to 0? Let's try to prove this. It has been given that x minus a is a factor of the polynomial p of x. So we can represent p of x as the product of x minus a and g of x, where g of x is any polynomial. Now, if we substitute a in place of x, we can clearly see that p of a will be equal to 0. Therefore, the converse is also true. That is, for any polynomial p of x, if x minus a is a factor, then p of a will be equal to 0. Now let's solve some problems on the factor theorem to understand it better. So here is our first problem. In this problem, we have to check whether x minus 1 is a factor of this polynomial f of x or not. So let's do it. From the factor theorem, we know that if x minus a has to be factor of the polynomial p of x, then p of a must be equal to 0. Similarly, if x minus 1 has to be factor of the polynomial f of x, f of 1 must be equal to 0. Therefore, we have to substitute 1 in place of x in the polynomial f of x. That is, we have to find f of 1 and check whether it is equal to 0 or not. So, if we substitute 1 in place of x in the polynomial f of x, we can clearly see that f of 1 is equal to 0. Therefore, from the factor theorem, we can conclude that x minus 1 is a factor of the polynomial f of x. Now, if there was no factor theorem, then for the same question, we have to divide the polynomial f of x by the polynomial x minus 1 and then see whether the remainder is 0 or not. Don't you think it is a very time-consuming process? So this is how our factor theorem is helping us. So thanks to factor theorem. Let's solve one more problem. In this problem, it is given that x plus 2 is a factor of this polynomial g of x. Now we have to find the value of k, which is the coefficient of x. Again, we will make use of factor theorem. Here the factor given is x plus 2. In our previous video, we saw how to convert these sort of factors into our desired form of x minus a. So we will rewrite x plus 2 as x minus minus 2. That means the value of a is minus 2. Since x minus of minus 2 is a factor of the polynomial g of x, by factor theorem g of minus 2 must be equal to 0. So if we calculate g of minus 2, we will get g of minus 2 equal to minus 10 minus 2k. And this should be equal to 0 since x minus of minus 2 is a factor of the polynomial g of x. So minus 10 minus 2k equals to 0, which implies 2k equals to minus 10 and finally k equals to minus 5. Therefore, the value of k, which is the coefficient of x, is equal to minus 5. So friends, I hope you understood factor theorem and how to use it in solving problems. We will be finding these two types of problems quite often. In our next video, we will be solving some more problems. As of now, let's summarize what we have learned so far. Let p of x be any polynomial of degree greater than or equal to 1 and a be any real number. If p of x is divided by x minus a, then the remainder is p of a. A divisor divides a number resulting in a remainder. When the remainder is 0, the divisor is known as the factor of the given number. If p of x is a polynomial of degree greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if p of a is equal to 0. If p of x is a polynomial of degree greater than or equal to 1 and a is any real number, if p of a is equal to 0, then x minus a is a factor of the polynomial p of x.